Hello friends, so welcome in the new video. This is continuation part of the interrupt. So till now in interrupt, I have demonstrated you various tasks related to interrupt, starting from simple external interrupt to nested interrupt, priority based interrupt, then UART interrupt, and in UART we have also seen the external module called GSM, how to send SMS, how to receive SMS, and you can do all these things using interrupt. And now this is next module called timer with interrupt, and this is very useful in real life time application also, right? So what is timer first of all, and what is timer with interrupt? So timer is basically, it's like a clock, you can say. It's like a countdown clock built inside the chip. So you can simply start the count, and when you reach a certain time you can do something, right? So for example, if I want to uh, you know uh, do something, I want to blink LED, I want to turn on LED, or I want to generate some sound after 5 seconds, after 10 seconds. So I can do it with the timer with interrupt, or simple timer as well, right? Let us say you have fire sensor, and if fire is detected by that sensor, but for one particular second it may be false detection, right? So you have to wait for certain time, not more than 5 minutes or 10 minutes, right? But you can at least wait for 3 to 5 seconds, that if fire is continuously detected by that sensor, then and then you have to generate some alert. So in that type of task, right, where embedded system is also doing multiple tasks parallelly, you cannot use simple delay. Like, you cannot hold that whole system for 3 to 5 seconds continuously without doing anything, just check the sensor, right? This is not practical way to do. So for that we have to use timer with interrupt. So simply, for example, you can ask it to wait for 3 seconds. So as I told you earlier, let us take that example only. Detect the fire, and if fire is detected continuously for 3 seconds, so what you can do, you can start the timer. When you detect, when detection start, you start the timer, wait until timer reaches 3 seconds, okay? And after 3 seconds, do something like perform some action. Either you can generate alert, you can turn on some light or buzzer, whatever. So this is how timer works, right? So our main core idea is handling delay and timing task is very crucial, right? It is very critical, because as I told you earlier, that if you have some robotics application, if you have some healthcare application, and if your delays are not properly handled, then if your microcontroller will go in one particular state where it is waiting for some input, then your overall system will be useless, right? So for that, handling delay is very critical. So till now what we learned, if I want to generate some delay, 5 second, 10 second, so we simply use HL delay. But this is blocking delay, because when HL delay function execute, microcontroller literally stops for that particular time. Let us say HL delay 5000, so microcontroller will not do anything for next 5 seconds. It will simply block overall operations. But with timer with interrupt, you can achieve non-blocking functionality. Non-blocking means what? So when timer start this count, okay, timer will simply enable the interrupt, and a microcontroller can do any other task in background. That interrupt will continuously generate, and your subroutine, you can simply count, okay, 5 time interrupt generate, then simply do this action. So this action will be in background, it will not block the microcontroller. Anyway, we will see this in our next demonstration, but for now, for understanding purpose, you have to simply understand this timer with interrupt is a non-blocking delay, right? Now let us take example, because in our demonstration I have to set certain value. So let us take example. So all know what is crystal, right? What is clock frequency? So let us say a microcontroller is having 8 megahertz of clock frequency. and your timer size is also there, right? Different microcontrollers have different size, 16-bit, 32-bit general purpose timer. So this is also not relevant for this video, so this is just for a knowledge purpose. Now if your clock frequency is 8 megahertz and if your task is to detect or you to overflow the timer at exactly 3 seconds, then you have to configure it, you have to configure some values, right? So you know, you understand the task, right? Your input frequency is given. Now you have to detect some delay. So timer means what? Timer means simply start count. It's like a stopwatch, right? Just start the stopwatch, it will continuously increase that count one by one and detect the overflow. You can choose any, right? You can say 10 second is my overflow, so after 10 second, exactly 10 second, you can do any task. Let us say if you just understand, or you just decide that okay, 20 second is my overflow, so after 20 second you can do certain task, like, so its timer is like that only. But to decide that overflow, you have to configure it, and for that you have two register. One is a prescaler register. This will also will going to configure in our application, in our program STM32, and another register is ARR, it's auto reload register. Now what is prescaler register? So let us say your input clock frequency is 8 megahertz. So this prescaler, it divides the input clock frequency to slow it down. Okay, so if your 8 megahertz crystal is there, okay, so your once you know, you can simply calculate time is equal to 1 by f. Okay, so that delay will be very very small, it's about 1 microsecond. So per cycle it will take 1 microsecond, right? Now you can slow down this using prescaler. So prescaler will basically divide your frequency with that value. So if your prescaler is 7999, so you can see here simply calculation, 8 6 times 0 divided by 799 plus 1, so it will reduce this 8 megahertz frequency to 1000 hertz, which is 1 kilohertz, right? And now if you will calculate time for this 1000 hertz, so 1 time is equal to 1 by f. So now your one tick will be of 1 millisecond. Previously it was 1 microsecond, now it is 1 millisecond. So per tick, per clock cycle, per tick means what? Per clock cycle. Okay, let me just show you what is per click tick. So this is what the tick is, right? This is one tick. So the time of this one tick will be 1 millisecond, right? So using prescaler you can slow it down. And second is ARR. So now based on our prescaler, our one tick's time was 1 millisecond. Now using this ARR, you can overflow your timer exactly at 3 seconds. How? So this ARR value will define how many tick to count before resetting or to overflow. Means how many, after how many ticks you want their counter should be overflow. And let us say is your ARI value is 2999. So simply multiply this 299 in plus 1 into 1 millisecond, and your answer is 3000 millisecond. So exactly 3 seconds. So if you will set prescaler register is equal to 7999 and if you will set ARI is equal to 2999, so your timer will automatically overflow after 3 seconds. And now if you will enable the interrupt, so after 3 seconds your timer will generate, will trigger the interrupt, right? And now using the interrupt subroutine, which we already discussed in our previous video, you can execute certain functions. For now, for this video we will simply turn on the LED, right? So this is how the calculation is you can configure. Okay, now so advantage is definitely MCU microcontroller can do other things while waiting, right? It is efficient because it is non-blocking mode, and it is perfect for multitasking, right? Because timer start counting in the background, so your main code can means keep running normally, right, without any blockage. So this is what the advantages of timer interrupt. And now let us compare this. So this is again by mistake, so I'm just removing this part. Last line is not relevant for this. Okay, so now if I want to do some experiment, so let us say this is my circuit. So here in circuit you can see I have one switch, one LED. So you can consider this switch as a sensor, fire sensor. Now when you press the switch, fire detects. When you release the switch, a fire not detect, right? So let us say now fire means sensor detects fire. Now still it is in press condition, so continuously time increase, right? Timer count is increases. Now after 3 or 5 seconds I want to turn on the LED with timer. So how we can do that? And if I will do same with delay, then what happen? So this is just that comparison. So if I will use HL delay, so definitely STM32 will wait. Okay, we will be busy for this HL delay function. Even after, if I will check continuously for 1 second interval, so STM32 will continuously in wait condition for the whole time period, right? And after 5 seconds LED will turn on. So during waiting, STM32 can't react to anything else with HL delay. But with the timer with interrupt, STM can start the timer, but CPU is free, because now once timer start, in background it will continuously observe. After 1 second it will generate the interrupt. In interrupt subroutine we will take particular action, and everything will be in background. Okay, so your microcontroller will be in free, it can do anything. And after that trigger, let us say after 5 seconds I want to turn on LED, so we will simply write a logic like that. After 5 seconds it will turn on the LED. Okay, so this is what the timer is interrupt. And for this experiment we will use this calculator. So our crystal frequency is s megahertz, so my prescaler value will be 7999 and my ARR value will be 999. Okay, and using these two value we can achieve the frequency 1 hertz. 1 hertz means if you will convert this frequency into time, so 1 second. Okay, so your each interrupt will trigger after 1 second. Okay, so we will use this calculation and I will show you in code also. So let us start the coding. Okay, so this is my circuit, so I'm just clearing the pins. Now as per our circuit, PA0 should be GPIO input, PA1 should be GPIO output. Okay, then I'm configuring this UART1 because I want to send some messages, so UART1 is also there. And our most important part is timer. So let us select timer 3. In timer 3 you have to simply click over the internal clock, and you will see the configuration part. In configuration part, in parameter setting, prescaler would be our 7999 and our this ARR will be 999, right? So now our using this setting you can achieve 1 second interval, right? But since we are using this Proteus, so that interval will be not exactly of 1 second, it will be more, because this is for simulation. But on hardware you can achieve exact delay whatever we want to set, but this is simulation, so the delay will be not exactly of 1 second. But for understanding, let us use this, and in next video I will also show you same code on hardware. Okay, so this is what the setting. Now second, this is timer but we want interrupt. Okay, now RCC is also required. We have to, now in NVIC, this is timer 3 global interrupt. Let us enable this. Okay, and in GPIO let us set this PA0 normally pull down. Why? Because when switch is in release condition, 0 volt should be there, right? So when no fire is there, so it should detect 0 low signal. When fire is there, it should detect high signal. So for now let us set this. Okay, now let us generate the code. So it will generate the base code, and in base code we will write our logic. right? So let us start with the functionality, basic functionality. So first of all, we will check the switch position, or we will check the sensor. If sensor is 1, means if a particular value sensed by the sensor, then start the timer. Okay, this is what we want to do. Okay, so for let us start with the while one. In while one, if our first task is to detect if our pin 0, so let us reuse this. Okay, in HL we have advantage that we have some functions pre-implemented, right? So let us reuse them. No need to remember everything, just reuse them. Now using this write pin function, also you can convert this into read pin. How? So simply here change this write to read. Okay, and this is equal to, right? If PA1, not 1, sorry, 0, because our switch is with 0. If PA switch is equal to reset, uh, now we want to set. If fire detected, then it will be set. So if PA0 pin is equal to set, then you have to do something, right? Now let us declare some variables which I'm going to use in my function. So first variable is, I will tell you the function of each variable. So present flag, this is to detect first time whether switch is pressed or not, and when switch press we will set this present flag to 1. Okay, let us declare another variable second count. This is because after each interrupt, after 1 second, we will increase this second count to by 1, and when we reach up to 5 seconds, then we will do some execution, right? So for that, so let us keep this also 0. Okay, and now I will simply use message. So our message is like character message, ongoing task, and our another message is message 1, which is done. Okay, so first time when person will press the switch or some fire sensor detect the fire, we will print this message done, and we will start timer, and now timer will continuously count its value in background. After reaches to overflow, it will generate the interrupt will execute the subroutine, right? This all process will be in background. So for now, just if this switch press and, we will also going to detect the value of present uh, flag, because when one first time switch press, only that time counter should start. Okay, not every time counter should start. So that's why I'm using this flag. So first time only I have to check if present flag is 0, and if the switch is pressed, right? Then and then do this. Okay, and then what, we will simply set this present flag is equal to 1, because now next time this loop should not execute, right? So now I'm just setting this present flag is equal to 1. With this, now I will start the timer. So for that, we have these drivers, we have our uh, timer.c file. So from this I will take some functions. Okay, so as I told you earlier, with HL no need to remember everything, we can simply use this function. So this is top function. I'm just copying this from here to here. Then another function is start. So I'm also copying this. And another function is for subroutine. So if interrupt generate, so it will execute this subroutine part, this function automatically. So I have to write this logic inside this function, and that's why I need this function. Sorry, this is my mistake. So it's yes, this is the function hl time period elapsed callback. So this callback function automatically execute when interrupt generates. So I'm going to use this function also outside the loop. So for now I'm just putting this over here. Now you can start the counter using the start it function, and in argument you have to simply pass the handler of the timer. So for our program it is h time 3 stm3. So now this will start the timer in background only, right? And here I will simply send some message on our UART, which definitely we will not going to see because our ongoing task will overwrite it. But for just for reference I am just writing this hl transmit, and this time our handler is UART1 because our UART1 is there. Okay, then our message, now our message is message 1, right? Done. So I have to simply write message strlen message 1 and simply timeout value 100. Okay, now let us typecast this also. Okay, so now when first time user will press the switch or sensor will detect this that fire or whatever quantity, whatever value, right? So it will simply set this present flag to 1. It will start timer with interrupt. Okay, and it will send some message on UART. That's it. Okay, now based on our setting, this timer will overflow exactly after 1 second, and after 1 second it will execute. Now let us use this function in this left time. So after that interrupt generate, it will execute this interrupt subroutine part. And now in subroutine part again we have to make sure that our interrupt is come from the timer 3 only, and for that let us write this in 3. Okay, with this, okay, with this I will also check whether my present flag is on or 1 or not, right? And for that recheck this present flag, because once present flag means one switch press, this present flag will be 1. Okay, so if both the condition will satisfied, then do something. What to do now? Inside this means let us say interrupt generates after 1 second. Now we have to make sure that the switch should continuously in pressed condition, and for that we have to again check, right, that switch is pressed in pressed condition. So for that check if my switch is in released or reset, then we will simply stop the counter. Okay, so if switch is in release condition, stop the counter. Okay, because we have to make sure that switch should be in press condition continuously for 3 seconds or 5 seconds. So if after 1 second if person will release the switch, so definitely at that time previous interrupt will generate, but now after generating the interrupt user release the switch, so it will simply come over here and it will stop the counter as from this only, right? uh, and it will simply set this present flag is equal to 0. Also it will set this second count is also 0. Okay, now if switch is still in pressed condition, then it will definitely going to execute in else part. And here in else part, what I will do, I will simply check how many seconds passed, okay, with pressed switch only. So let us increase this second by 1. If second is less than 2, for now I'm just using this small value because this is not actual hardware, so your 1 second will be more, right? Time is large because this is simulation. So let us wait for only 2 seconds, and if the second reaches to 2, then we have to simply stop the counter because only one time we are checking is, and turn on the LED. So our LED is with PA1. Okay, so turn on the LED, and if in between user will release the switch, turn off the LED. Simple logic, right? So this is our overall logic. Now let me check here, some mistake is there, I think, right here one bracket is missing, right? So now when user will press the switch, it will set this present flag, it will start the timer, it will send some message. Now timer starts. So after each second, based on our setting, prescaler and ARR setting, after 1 second this interrupt will generate, it will execute this subroutine, it will check my interrupt is from timer 3, present flag is set. So now again it will check still switch is pressed or not. If not, then it will simply stop the timer, it will reset this present flag and second count, it will turn off the LED, right? We will not observe anything on LED. But if switch is still in press condition, it will continuously increase the second count by 1, and if this interrupt will continuously generate for 2 to 3 times, right? So this condition will satisfied, it will stop the counter, it will turn on the LED. So you will see that LED will turn on after 2 seconds. Again, this is simulation, so this 2 seconds will not exactly 2 seconds. Okay, but for understanding, let us take 2 seconds. Now, as an ongoing task, I will simply print some message on UART, and the message will be our ongoing task message, right? This message. Okay, now here semicolon is missing. Now let us simply debug this code. I will simply debug the code and then I will load it. Again, you have to make sure this is simulation, so your timer will not miss, our time will not exactly, right? Some error is there, let us check this. Instance, sorry, instance, right? Check this. Now generate the hex file, take the path, because to generate the hex file we have to remember this path, convert hex file. Now generate hexadecimal file, and we will going to upload this on our circuit, right? Okay, still I think it is generating. Okay, still it is not showing hex file. Okay, apply and close. Now again release the project. Now it should generate hex file. This is now Now when I will run this, you can observe the UART, right, ongoing task. Now I'm just pressing this switch. So now you can see one message was there, but it was overwritten by this. So now after 2 seconds this LED will turn on and this UART will stop, because in background this timer is start counting, right, and it will generate the interrupt after 1 second. But since this is simulation, so our 1 second will be last. Now you can see LED is on, right, means our execution completed, right, and still you can see our ongoing task is executed, right. So this is what the unblocking mode. So you can see our ongoing task was continuously on while timer handle this delay properly. It count this continuously, and after 2 seconds it turn on the LED. So sensor senses the value, sensor senses the fire or whatever quantity, whatever thing you want to send. In background it continuously increase the time, and after 2 seconds it performs specific action, right, while without blocking the current ongoing task. So this is what the timer with interrupt. So this is what for today's video. In next video I will demonstrate this on actual hardware. I will put this code in my description of this video. So if you like my work, please like my videos, subscribe my YouTube channel, share these videos with your friend, and please support me so I can keep making this type of videos for you in future. Till then, bye bye. Thank you very much.